Hi everybody, I'm going to make a video here solving some of the questions from the workbook number 15. I know that we just went over this and I did some of them on the board, but I just want to make a video because it seemed like a lot of people had trouble with that. So I'm going to start out here with, this is 15b. Okay, so we have a quadratic equation here, and I know this is a quadratic equation because I have this x to the second power. And what we need to do here is we need to get a 0 on one side. And I'll remind you why in just a second, but let's do that first. So I'm going to leave this left side alone, basically. And in my head, I'm thinking, I want to get rid of this 13x. So what I'm going to do is I'm going to subtract 13x from both sides. Okay, now over here I'm going to have 2x squared minus 13x minus 45 is equal to 0. Okay, now the whole reason that we want to do this, this is very important, excuse me, the whole reason we want to do this is because we want to take this here and factor it into something that looks like this, right? So we're going to have like 2x plus something, x plus something over here. Now, once I get that, I can reason, I can say that if I'm multiplying two things together and my answer is 0, one of these things must be equal to 0. So then we take these factors and we set them equal to 0. Okay? So the way we're going to do this, the way that we factor this is a hard case quadratic because it's got the 2 in front of the x squared. It's not just x squared. So the way we learn to do this, well, we learned a couple of ways, but the way that most of you are comfortable with is the box method. So I'm going to take this and plug it into the box to factor this. Oh, that's a terrible box. You know, I actually have a box tool. Let's just do that. There we go. Still not the greatest box, but that's fine. So top left is going to be my x squared term. Bottom right is going to be my constant term. Multiply the two together. I need two numbers that multiply together, or two terms, I should say, that multiply together to equal negative 90x squared, and add together to equal negative 13x. Okay, so they multiply together to equal negative 90x, and add together to equal negative 13x. Well, I want to start with 90. I'll start by factoring 90. I know that 9 times 10 is 90. If one of those is negative, well, that would mean that my difference is only 1, so that's not going to work. Okay, let's see here. I could do, well, we know the answer. The answer is going to be 18 times 5. Now, if I make the 18 negative, so negative 18x, and a positive 5x, when I add these together, I get negative 13x. Okay, next step. Take this and move this a little bit. The next step is to take your greatest common factors of your rows and your columns, and then those things are going to be the factors over here. So my greatest common factor here is going to be 2x. Greatest common factor here is 5. So I know one of my factors is going to be 2x plus 5. This was a positive 5. Greatest common factor in this column is x. Greatest common factor here is negative 9. So this factors into 2x plus 5 times x minus 9. And that's still equal to 0. I'm going to leave this up here, but I'm going to shrink it down a little bit in case I need more room. Okay, so that's the factored expression here. I took this quadratic trinomial and I factored it into two binomials. Now, what this says is I've got two things, this factor here, I'm just going to draw it. This whole thing here is a factor, and this whole thing here is a factor. And when I multiply these two things together, I get 0. So what that means is that one of them must be equal to 0. So what I'm going to do is I'm just going to set them both equal to 0 and solve. So I'm going to say, what would x have to be for 2x plus 5 to be 0? Well, we'll just take this and solve this like a regular equation. So subtract 5 from both sides. Divide by 2, 2x equals negative 5, divide by 2, and x is equal to -5/2. Now the other thing we need to do is set x minus 9 is equal to 0. And this is pretty easy to do. You just add 9 to both sides. X is equal to 9. Okay, so the steps were, the first thing we had to do when we had this up here, the first thing we had to do was get a 0 on one side. That's always, when you're factoring quadratics, that's the first thing you have to do. Get a 0 on one side. We did that. Then we had to factor this thing on the left side. We used the box method to do that. Once it's factored, we take both of these factors, the 2x plus 5 and the x minus 9, and we set them equal to 0 and solve. And that's it. That's how you get your two solutions. So my solutions would be x equals -5/2 and x equals 9. Okay? Let's try another example. Now this one, okay, I saw a lot of people had trouble with this. Let's just go through this. Now I'm going to do the same thing I did before. I want to get a 0 on one side and then factor. To do that, I have to expand here by distribution. So I'm going to multiply 2x times x and then the -18. So I get 2x squared minus 36x is equal to x. Okay, well I still want a 0 on this side, so I'm going to subtract x from both sides. 2x squared minus, well, -36x minus x is -37x. And this is equal to 0, because x minus x is equal to 0. Now, we do the same thing. We have to factor this. And this is actually easier than any other type of quadratic that we run into. So what I do is I factor out the greatest common factor, which is x. So this becomes factor out the x, kind of pull it out like we're undoing distribution. 2x minus 37. This is equal to 0. All right, now we're going to do the same thing we did in the other step. This is factored, so I'm going to set each one of the factors. Here's a factor right here. X is a factor. The other factor is this thing in parentheses. So let's set them both equal to 0. So either x equals 0 or 2x minus 37 is equal to 0. Now this one's already solved for you. It's kind of given to you. Could be 0. If x is 0, then that makes this whole thing true. But this one we have to do a little bit of work. So we add 37 to both sides into our basic algebra here. 2x equals 37. Divide both sides by 2. And x is equal to 37 over 2, which is 18.5. Or 37 halves is acceptable as well. Okay, so in this case, when we get something that looks like this, okay, now how is this different from this quadratic over here? Well, it doesn't have a constant term. This quadratic is a trinomial. It's got x squared, x, and a constant. The one we just did, there's no constant here. So what that means is we can factor an x out, like I did right down here. And once it's factored, you do the same thing you always do. Set both factors equal to 0 and solve. So I know a lot of people have trouble with that, but once you get the hang of it, it's actually easier than doing it the other way. Because we don't have to do any box method or anything. Okay. One more example. Same strategy. Our goal is to get a 0 on one side of the equal sign and factor the other side. So let's start by expanding. I have to expand these parentheses so that I can subtract this x squared and this 5 off to get the 0 that I want. So squaring this, you get 4x squared plus 4x plus 1 is equal to x squared plus 5. Okay, I really want to get a 0 on one side of this equation, so I'm going to subtract x squared. And I'm also going to subtract 5. Okay, so 3x squared plus 4x minus 4 is equal to 0. Okay, this is the thing that I want to factor right here, this quadratic trinomial. So we're going to do the box method. That's so much better at drawing lines than I am. Okay. My x squared term goes in the top left. Constant, which is -4, goes in the, I should move this because we need to factor to the top. -4 goes in the bottom right. Multiply the two together, I get -12x squared. And when I add my two factors together, I need to get +4x. So I need two things that multiply together to equal -12 and add together to equal +4. Now, because this is negative, one of my factors is going to be negative, one's going to be positive. So I'm going to have +6x minus 2x. Now, I've noticed that you're pretty good at that as a whole. The class is very good at finding the two numbers that fit this description. Our box is filled out, so now we're just going to factor. Factoring along the top row, the greatest common factor is 3x. Along the bottom, because this is negative, I'll have a -2. Okay, so there's my first factor, 3x minus 2. And going along the columns, I get x plus 2. Okay, this trinomial here, put brackets around it, is the exact same thing as these two factors multiplied. So it's still equal to 0. Now what we're going to do is we're just going to take this and we're going to set both of these factors equal to 0 like we always do. Once we have a factored quadratic, we just set both of the factors equal to 0. So 3x minus 2 can equal 0, in which case x is going to be, what am I doing here? I'm trying to skip steps. So 3x is equal to 2, added 2 to both sides, divide by 3, and x is equal to 2/3. Okay, that's one solution. Our second solution comes from our second factor. X plus 2 is equal to 0, so x is equal to -2 by subtracting 2 from both sides. Okay, there are my two solutions. So to recap, whenever we have a quadratic expression like this, or a quadratic equation, we know it's quadratic because of these second powers, the exponent, the 2 exponent. We need to get a 0 on one side, factor the other side, set the factors equal to 0, and solve. But that's one thing that I see people missing, is you have to, especially on this type of problem, you have to understand that when you pull that x out, that is a factor. What's left in parentheses is another factor. You have to set them both. Here's one, here's the other. You have to set them both equal to 0 and solve for x. All right, I hope that helped. We're going to keep working at this, and your test is on Thursday, so we've got plenty of time for questions.